Hello, my fabulous students. So I've been telling you about how we're going to be solving to complete the square for a while. Okay, so what we've been doing up to the completing the square point, I showed you in example 1 and 2 how to solve by rewriting the left-hand side of your equation as a perfect square trinomial or as a binomial squared, and then you solve the equation by taking the square root of both sides and using the square root property. So we're going to be using the steps that I taught you in example 1 and 2 to solve by completing the square. But what we're going to do is we're going to have a quadratic that is not a perfect square trinomial. Okay, and we're going to force it to be a perfect square trinomial by doing our nifty formula that I taught you, the b over 2 squared. So after we force this thing to be a perfect square trinomial, then the steps will be very similar to what we did in example 1 and 2. So it's kind of like we're combining everything we talked about in example 1 and 2 and examples 3 through 5. Doesn't that sound like fun? I know. Okay, so completing the square, when you solve by completing the square, this is another technique that you can use to find the zeros, the roots, the x-intercepts, the solutions of a quadratic. And this technique, like the quadratic formula, works every single time. So if you like completing the square and you hate factoring and you hate using the quadratic formula, well, guess what? You can solve your quadratic by completing the square. All right, well, let's get started on example 6. Okay, and again, my screen is frozen. Sorry, guys. Okay, we're back. Okay, good. Okay, anyway, so example 6, we're going to be solving by completing the perfect square trinomial. So I like to call it solve by completing the perfect square. A lot of people just call it solve by completing the square. Okay, and you don't technically need this trinomial part. I don't know why I put that in there. Sorry, guys, you don't really need this. I mean, it's not wrong to have it, but I didn't mean to put it there. Sorry about that, you guys. The demon cats are getting me. Good golly. Alright, but anyway, so we're going to be solving by completing the square, but I like to call it solve by completing the perfect square, because we are going to force one side of our equation, whether or not it wants to be, we're going to force it to be a perfect square trinomial. Okay, and we're going to do that by using our nifty formula, that b over 2 squared. Okay, well, let's get started. Okay, so the first step that we do when we're solving by completing the square, we're going to put all of the x squared terms and all the x's on one side. So we're going to have all the x's on one side, and then we're going to have all the terms without the x on the other. So the x's like each other, okay? They like to be on the same side of the equation. Okay, so all the x's on one side, everything without an x on the other side. So we're kind of separating the terms with x's and the terms without x's, which I know is kind of mean, but it'll all work out in the end. Okay, so if you guys notice here, currently I have a -9 on the left side of my equation, and it doesn't have an x. So I need to move this term over to this side. So I'm going to be moving this term, my -9, I need to move it onto that side of my equation. Okay, because all the terms without the x are going to go on the right-hand side, and all the terms with the x's are going to go on the left-hand side. Okay, so I'm going to bring, I spot on the left-hand side of my, right-hand side of my equation that I have a term with an x, which means it needs to go onto the left-hand side of my equation. Okay, so this -x needs to go on the left-hand side, and the -9 needs to go on the right-hand side. So I'm going to be moving these two terms onto the other side of the equation. Okay, so I'm going to start by moving -x to the other side, which the way I move -x over is by adding it on both sides. So I'm going to add x on both sides, which don't forget, you guys, there's secretly a 1 in front of the x if you don't see anything. Okay, now, how you know which term to add this to is the term that is like terms with the x. Which term on the left-hand side is the like term of x? Holy hot dog, you guys, that would be the 9x, because x is to the first power. So I'm going to add the 1x to the 9x. Okay, which -1x plus 1x will cancel and turn to 0. 9x plus 1x will give me 10x. Okay? And now I need to move negative 9 to the other side, which the way I move negative 9 over is by adding it on both sides. Okay, and again, I need to add the 9 to its like term, which the only term that is a like term with 9 is the 2, because it doesn't have an x. So I'm going to add it to the 2. So negative 9 plus 9 will cancel and turn to 0. 2 plus 9 is 11. Okay, so let's see what we're dealing with right now. Okay, so right now, I'm going to kind of write it over here. Here we have x squared, and then we have plus 10x. Okay, and then on the other side, this will equal everything over here, which is just the 2 and the 9, which is 11. Okay, so we have separated the x terms and the terms without the x's. Okay, so that is always the first step you do when you are trying to solve by completing the square. Okay, after this, you guys, it is very important. Your a value at this step must be 1. If it is not 1 and you try to complete the square or try to solve by completing the square, it will not work out. Okay, which if you guys see here, look at that. My a value is already a 1 because I don't see anything. So I'm good to go. So my a value is 1, which means I'm good to go. Okay, so after we rearrange the equation, I put all the x's on one side and all the terms without the x's on the other. This is when we're going to be a little mean. We're going to force this side of the equation, the left-hand side, to be a perfect square trinomial whether or not it wants to be. We're going to be kind of mean. Okay, and the way that you force that to be a perfect square trinomial is by using that nifty formula that you learned in examples 3 through 5, which is the b over 2 squared. So b over 2 squared. Okay, which my b term is the one in front of the x. So my b is 10. All right, let's solve this thing. So let's see here. My b term is 10. Okay, and 10 over 2 equals 5. And 5 squared is 25. Okay, now, what we did in examples 3, 4, and 5 is I just kind of added it on to this quadratic right here. We didn't have this equation in the other one. Okay, so we're going to have to do something a little bit different in this one since we have an equation. Okay, so currently I already know that's a 1, so I'm going to bring that on down. So I have a 1x squared, and then plus 10x. So plus 10x. And then I end up with a 25, and I'm going to add it to my quadratic that I currently have, so then it will be a perfect square trinomial. So I'm going to add 25. Okay, this is the brand new term that I'm going to add to make sure that this is a perfect square trinomial. And then on the other side, I'm going to bring down this 11 because it's already there. Now, since we have an equation, okay, equations must stay balanced. If they don't stay balanced, then they don't make any sense. Okay, which if you guys see here, my equation up here did not contain this 25. Okay, so when I add the b over 2 squared to one side of the equation to keep it balanced, I also have to add it on the other side of the equation. So when you guys do the b over 2 squared, you have to add it on both sides of the equation. Okay, you have to. And that way your equation will stay balanced. You can't just start adding random things on random sides of your equation. That's when the demon cats will get you. Okay, so as of this point, this is kind of like what we were doing in examples 1 and 2. I now know that this will be a perfect square trinomial, so I can factor that or do that shortcut I taught you. And then after that, we should be able to solve really quickly. Okay, so if you remember the shortcut, since we now know that this right here, this bad boy, is a perfect square trinomial, I can do the shortcut where I square root the first term and the last term, and then I take the sign of the middle term. So let's square root the first term and the third term. Okay, so my first term is this 1x squared, or just x squared. Okay, which the square root of x squared is x. Okay, the square root of my third term, well, that's 25. and the square root of 25 is 5. Okay, and then don't forget we're going to take the sign of the middle term, which the middle term, or my second term, is a positive. Okay, so I can rewrite this side like so, like this. I can rewrite it as x plus 5 quantity squared. So I'm going to write these two numbers in here. I'm going to bring on these bad boys into my parenthesis, and I'm going to take the sign of my second term. Okay, so now I can rewrite my left-hand side like so. I'm going to leave the right-hand side alone. Don't touch the right-hand side. Okay, I'm going to bring this up here because if you can see, I'm already out of space. Okay, yeah, I think I'll have enough room. We'll see. Okay, so now I have x plus 5 squared equals, now my right-hand side is 11 plus 25. What is 11 plus 25? That's correct. It is 36. Okay, so now this is where we can solve. Since I have a squared, I need to eventually get rid of that squared. What is the opposite or the inverse of a squared? Holy hot dog. That would be square root. Okay, so in order to solve this, when you have a squared, you guys, you have to use the square root property, which tells you to square root both sides of the equation. Okay, so to solve for x from here, I'm going to be square rooting both sides and solving for x, which from here, this should look very similar to what we did in example 1 and 2. So if you want to kind of take it from here and see if you get it right, I say go for it. Otherwise, let's start square rooting. So I'm going to square root both sides of the equation. Okay, so the square root will cancel out the squared, and what I'm left with is this x plus 5. Now, don't forget, when you square root both sides of an equation, what will appear on the right-hand side? Exactly, a plus or minus will appear. And then, what is the square root of 36? That would be 6. Okay, and from here, I just need to get x on one side by itself. So I need to bring positive 5 to the other side, which the way I do that is by subtracting it on both sides. Which 5 minus 5 will cancel and turn to 0. And then remember on this side, you guys, typically we keep the plus or minus with the 6, and we're going to write this second. Okay, and we're going to write this negative 5 first. So it's going to look something like this. X equals negative 5 plus or minus 6. And then from here, we have two possible solutions for x. So we have x equals negative 5 plus 6, or x equals negative 5. So one time we do the positive. The second time we're going to do the negative. So negative 5 minus 6. Okay, so now we have negative 5 plus 6 is 1. Or x equals negative 5 minus 6 more is negative 11. So guess what, you guys? The x-intercepts, the zeros, the roots, the solutions could be 1 or negative 11. Okay, so again, this is another technique for solving for x, which I've taught you 3 up to this point. Okay, you can solve by either, the first way I taught you was by factoring and setting your factors equal to 0, which guess what? That could have worked on this one. You just have to make this side equal to 0 first. The second technique I taught you was solving by the quadratic formula, which I know you guys are already singing the song because it's awesome. Okay, which don't forget, for the quadratic formula, you have to make sure this side is 0 as well. And then the third technique is to solve by completing the square. And again, you don't make this side 0, you bring the x's on one side and the numbers without the x's on the other, and then you have to use the b over 2 squared to write it as a perfect square trinomial, and then you just solve for x. So, those are the 3 ways you guys can solve for x, which really, if I ask you to solve for x or to find the zeros or roots or x-intercepts or solutions of a quadratic, you get to decide which technique you use. Now, sometimes completing the square we're going to have to use if we're rearranging our quadratic into a different form, but we're not going to talk about that yet. Okay, way to go, you guys. Let's get going on example 7.